Hi everybody, I am going to discuss three-layer architecture of DBMS. Three-layer architecture, three-layer architecture of DBMS. This is a very important question in semester examination. Three-layer architecture of DBMS. In 1971, conference on data system, conference on data system and language, conference on data system and language, CODASIL, conference on data system and language, CODASIL, appointed a database task group, DBTG, database task group, that is DBTG. In 1971, conference on data system and language appointed a database task group, DBTG. DBTG provides the general architecture. DBT provides the general database task group provide the general architecture of database design. In 1971, Conference on Data System and Language, CODASIL, Conference on Data System Analysis and Data System Data DA, System ASY and Language L. So this is the full form of CODASIL. Appointed a database task group. DBTG provides the general architecture of database design. It is the main source of development for the creation of three-layer architecture. DBTG provides general architecture of database design. In 1975, this is the history of the creation of three-layer architecture. In 1975, ANSI, American National Standard Institute, and SPARC full form is Standard Planning and Requirement Committee. Standard Planning and Requirement Committee. That is Standard Planning SPARC. In 1975, ANSI and SPARC provides three-layer architecture of DBMS. In 1975, ANSI SPARC provides three-layer architecture of DBMS. Three-layer architecture of DBMS known as ANSI SPARC architecture. This architecture is very useful in DBMS. So in 1975, ANSI and SPARC provides three-layer architecture of DBMS known as ANSI SPARC architecture. According to ANSI SPARC, so this is the basic concept of three-layer architecture. So in 1975, ANSI and SPARC developed this architecture. DBMS has three layers. All level. DBMS has three levels or layers. Number one, external, that is user accessible layer, external or application external or application or view layer. So this is the first layer, that is from the user point of view. This is user accessible layer. This is external or application or view layer. Number 2, logical or conceptual layer. Logical or conceptual layer. Number 3, this is the second layer, that is logical or conceptual layer. Number 3, physical or internal layer. So these are the 3 layers of DBMS. Every ANSYS Spark in DBMS architecture, every DBMS architecture based on this ANSYS Spark layer. So there are 3 layers. That's why it is known as 3-layer architecture of DBMS. Now we have to draw the basic concept of 3-layer architecture. So this is the layers of DBMS. Now we have to draw the 3 layers of architecture of DBMS. These are the users. These are users. Every user has its own view. So every user has its own view. User 1, user 2, user there is user 1. Suppose there is user 1, user 2. There are many users. Many user has its own view. This user view 1. These views are available in this view layer. So every user has different view. View 1, user has view 1, user 2 has view 2, user n has view n. So these are the view of users, and this layer is known as application layer. This layer is known as application layer. This is the user interaction layer. Next layer of DBMS is, this is the second layer of DBMS. This is logical or conceptual. Logical, or this layer is application layer. This layer is logical or conceptual. This is logical or conceptual layer. The second layer, this is the second layer of DBMS, and the third layer is, this is the physical layer. This is the physical layer. This is the third layer of DBMS. All these 3 layers are within the DBMS software. This is the DBMS software. This is the management system software. This is an application program, and this DBMS software consists of 3 layer: application layer, logic layer, and physical layer. And physical layer is connected to databases. Physical layer is connected to databases. This is our databases. So these 3 layers of DBMS consist of outside is users. We know that DBMS is the interconnection between users and the database. So there is a interface between the users and database. It consists of 3 layers. First of all, application layer. This is the outside part of the layer. Next is logical or conceptual layer, and the third one is physical layer. Physical layer is connected to the databases of the system. So these are the 3 layers of DBMS. This layer is known as ANSYS Spark architecture, and this architecture is known as ANSYS Spark. The data available or the information available in the application layer is converted to logical layer by the mapping function. There is a application slash mean two-way application slash logical mapping. There is application slash logical mapping, logical slash physical mapping, and vice versa. That is, it can when we insert data, that is from the application layer to logical to physical. When we accessing the data from the database, then physical to logical to application. This is the way of conversion of data from one end to another end. This is the basic architecture of ANSYS Spark. Now the functions of every layers. Now the functions of every layers. Now the functions of every layer. First layer is application layer. First layer is application, or that is the view layer, application layer. It is also known as view layer. It is the point wise you have to write. It is the users. It is the users of the database. It is the users of the database. It is the users of the database. This is the first point, because it is the user interaction layer. It is the highest level of DBMS. It is the highest level of DBMS. It is the highest level of DBMS because it is a user interaction layer. So these are the two points. First point is the user it is the user of the database. It is the highest level of DBMS. The third one is it deals with the way in which data is viewed by individual user. It deals with the way in which data is viewed by individual users. How different user access the DBMS, it depends on this layer. So there are different views according to different users. So it deals with the way in which data is viewed by individual users. Next, it deals with the way data is viewed by individual users. Next, it specifies views of data in terms of it specifies views of data in terms of conceptual level table. That is, it is for multi-user view. This level is specified multi-user view. It is the user interaction level. It is called view level because several users can view their data from this level. So these are the points. It is the users of the database. It is the highest level of database, DBMS. It deals with the way which data is viewed by individual users. It specifies the view of the data in terms of conceptual level tables. Next, it is called view level. It is called view level because several users can view their desired data. Several users can view the desired data from this level. This is called view level because several users, যেটা আমরা আগে দেখেছি, বিভিন্ন users application layer সাথে connect থাকে with the help of different views. It is called view level because several users can view their desired data from this level. Several users can view their desired data from this level. So it is called application level or application layers. This is the first layer of DBMS and it is the user interaction layer. And the next layer is logical layer. So this is the first layer of DBMS. The second one is logical layer. And the second one is logical layer. The first one is application layer. Second one is logical layer. This level describe what data. First of all, which data. Second one is what data. This level describe what data is stored. What data is stored in the database. What data is stored in the database. What data is stored in the database and the relationship among the data. This level describe what data is stored in the database and the relationship among the data. This level describe what data is stored in the database and the relationship among the data. It's a very important concept through which, that's why it is conceptual level. It's describe the conceptual thing among the relationship and other things, security concern, all other things done by this layer. This level describe what data is stored in the database and the relationship among the data. It provides all entities their attributes, and their relationship, It provides all entities, their attributes on different kind of entities, like suppose student name, student, employee. These are the entities, their attributes. Suppose student name, roll number, department. These are the attributes, and the relationship is one table is connected to another table, or is there any relationship between different tables. So we have to provide all the information in this layer. This provides all the entities and their attributes and their relationship. Next, it provides constraint. It provides different constant, integrity constant, domain constant, reference integrity constant. It provides constraints, constraint, constraint, or the data integrity, It provides constraint or the data integrity. These are the very important points. It provides security. It provides security. It provides security and integrity information. It provides security and integrity information. So this level describe what data is stored in the database, relationship about data, attributes, entities. It provides constraint. It provides protection and security. That is very important concept of database. So this is the different functions of this layer. At this level, data is presented in form of database. Actually, in this level, so these are the tasks of this logical level. At this level, but in this level, data is represented in the form of database table. In this level, that is logical level. In this level, data is presented in the form of various database table. It is very useful for database DBMS design. It is very useful level for DBMS design. So in this level, data is represented in the form of various database tables. Now the last layer is the physical layer or internal layer. This is the lowest level. Application layer is the highest level, and physical layer or internal layer, this is the lowest level of DBMS. The first point, it is the lowest level of DBMS. It is the lowest level of DBMS. This is the first point. The second one, this level describes how the first level application which, and the second level what data, and what are the relationship, what are the security concern, and this level is how. So first is which, what, and how. These are the very important terms to remember the functions. This level describes how data is stored. In the database. How the data is stored in the database. And it concern with the way data is stored physically. This level describes how data is stored in the database, and it concerned with the way data is stored physically. In the hardware. So this level describes how data is stored in the database. This is the lowest level of DBMS. It specifies record placement. In the hard disks. it specifies record placement, it specifies data compression, it specifies data compression, it specifies data integration, and that is the integration, encryptions and data encryptions and decryption techniques. So these are the functions of physical layer or internal layer. First layer is application layer, second layer is logical layer, and third one is internal layer, that is physical layer. And internal layer is connected to databases. So first layer specify how users are connected. Second layer is what data are there, what are the relationship among there, protection securities are there, and the third layer provide how to store the data in the DBMS, how that store the data in the database, actually how to store the data in the database by DBMS. So these are the three layers of DBMS, and these three layers are known as ANSI Spark architecture. This architecture is very useful architecture in the design of DBMS. So these are the layers of DBMS. Now this layer can be diagram in the form. Suppose this is the user interaction layer. This is the user interaction layer. This layer is user interaction layer. This layer is user interaction, and there are different view. These are the external view. So external view 1, it consists of C++ and DML. Suppose external view, there are different view depending on the different users of the DBMS. External view 2, that is suppose C++, and that is suppose Java and DML. DML means data manipulation language, and that's suppose Java and DML. Next is suppose external view. There are many view depending on the many users. These are the views. Suppose this is external view 3, that is based on COBOL and DML, common business oriented DML. So suppose these are the views, or these are known as, there are many views. Suppose these are the external view N, that is Java. Interactive, you can interactive DML, I can use interactive DML. So depending on different view, different user can access the DBMS. So these are the user interaction layer. All these user interaction layer, they are external schema. All are external schema. Schema mean the external architecture. These are all external architecture. They are all external architecture. So these external views are connected. These external view are connected to the next level, that is the user interaction layer, and next level is logical records interface, that is logical record interface, that is logical record interface. This layer is known as logical or conceptual level. This level describe logical or conceptual level. So first one is external level, that is there are different views, that is in user interaction layer, and the second is logical or conceptual level. This is the level where how data is what data is stored, what are the relationship of data. Next there is a internal layer, then there is an internal level, and this consists of store record interface. This consists of store record interface. This is the store record interface. There are some this is the logical level, so there are some logical schema. This is external schema, there is logical schema, there are logical schema, and the next level is physical. So in this level there is a physical schema, there is a physical schema, and it consists of store record interface. This interface is known as store record interface. This record is logical record interface, and this user interaction interface means area through which you can transfer data from one layer to another layer. Store record interface, and the lowest layer is the physical layer, that is internal layer is done, that is physical layer, this internal layer is done. These consist of physical model, and this physical model is based on is connect to hard disks, that is based on database. and this database is operated by operating system. These three levels are connected. These three levels are connected. These three levels are connected by WAS, that is DBMS, and this layer is functioned by operating system, because our data to be stored in the file system or indexes or anywhere. So we need operating system, and these three levels, that is view level, logical level, and internal level. Internal level mean the physical level where the physical records are stored. So physical records are stored. That is, it consists of external schema, it consists of logical schema, it consists of physical schema. These are the three layer that are grouped together to make ANSI Spark architecture. So ANSI Spark architecture is a very important question. Next, consider the example how these levels are operates. First of all, suppose there are two tables. The first table consists of external level, that is external level, that is view 1. The first table is suppose student name, that is roll number. First of all, roll number, and then name, address, roll number, name, address, and these are the suppose table, roll number, name, and address. This name of the table is student. Suppose name of the table is student. And the second is external level view 2. This is the view 2. Suppose roll number, name, department, roll number, name, department. These are the marks. This is the student table, and this is suppose a mark table. So these are the two table. There are different views, and these views are connected to the logical level. So this is view level, this is view level, this is view level, this is logical level or conceptual level. This is logical level or conceptual level. Conceptual level group this data from different external sources. This is row number, name, address. There is in the row number, name, department, marks. So these source of data are grouped together in this level. First one is row number field. There is a field name. This is the field name or data type. In this level, what data to be stored in the DBMS and how they are connected. First of all is row number is there. Row number is common in both the table. So row number, first data type is varchar 2, that is suppose row number is number, that is integer. Row number is number. Suppose row number is 3 mean 0 to 999 can be entered. So the row number is the first field, and the second field is name, and the name is character, that is varchar. Suppose size is 100, and this is the varchar 2. Next is address. This is also varchar 2, that is suppose 200 size, 200 character. And next one is department. Again varchar, suppose size is 30. And the next one is mark. Mark is number, and that can be float. Suppose there is a 5, 2. So the total width is 5, and after decimal is 2. So this is the purpose of the conceptual level. So this is the purpose of the view level. This is the purpose of the conceptual level. Now the last level, that is the last level, all these fields goes to the storage capacity, the lowest level. Now the lowest level is lowest level, and the lowest level is stored item and length. Stored item and length. So this is stored item means roll number. There is roll number. Type is equal to byte, and size is here 3. Type is byte, size is 3. Length is roll number is the stored item. Type how much byte required, 3 byte. The size is 3, and the offset is starting location, that is equal to initial 0. Then name type byte equal to byte, all are stored in byte, that is 100 byte equal to 100 bytes within bracket 100 byte, offset equal to 3, because 0 the starting location of the row number and the end is because byte row number is equal to 3 byte, so 0 plus 3, so offset is 3. Now address equal type equal to byte, that is 100, 200, and the offset will be 0 is the starting, then 3 added, then 100 added, offset is 103. So this is the address. Next is department. Department is type equal to byte, that is 30 byte required, offset is added 113 plus 200, that is offset equal to 303. This is the department. And the last one is marks. Marks is type equal to the number, that is in the byte, type equal to byte equal to 5, total size is 5, and the offset is that is 303 plus 30, that is 333. So offset means the starting location. The row number start with 0, then row number, the size of the row number is 3 bytes, so 0 plus 3 added, then at the 3 position name start. Then after the name end 100, its length is 100 byte, so 3 plus 100 mean address will start from 103. Then the department is 200, address is 200, then department will start after the address end, mean 103 plus 200 mean 303. Then department is 30, so offset will start from 303, and the marks is by type byte 5, that is 303 plus 30. So marks will start 303 and end with 333 and end with 338. So in this way you can use 3-layer architecture of DBMS. তো 3-layer architecture of DBMS থেকে আমরা যেটা জানলাম, পরীক্ষা যে মার্কস আছে, ডিপেন্ডিং অন দ্য মার্কস, তোমরা এই পুরো অ্যান্সারটা আমি ডিটেল দিয়েছি যাতে পুরো কনসেপ্টটা তোমাদের ক্লিয়ার হয়। বাট ডিপেন্ডিং অন দ্য মার্কস ইউ ক্যান রাইট দ্য অ্যান্সার। First of all, you have to say that there are 3 layers, then draw the diagram of 3 layers, then write the functions of every layers one by one, point wise, and then finally you can you can write this technique through which we can take 2 table. তোমরা এখানে দুটো টেবিল নিতে পারো, একটা স্টুডেন্ট, একটা যেমন আমরা নিয়েছি স্টুডেন্টের মার্কস, সেই স্টুডেন্টের মার্কসের ভেরিয়াস অ্যাট্রিবিউট দিতে পারো, সেই অ্যাট্রিবিউটগুলোকে কানেক্ট করছে লজিক্যাল লেয়ারে গিয়ে সেই সাইজটা স্পেসিফাই হচ্ছে, বাইট ক্যারেক্টার স্পেসিফাই হচ্ছে, অ্যান্ড থার্ড লেয়ারে গিয়ে যখন ফিজিক্যাল লেয়ারে আসছে, যখন আসছে সেটা স্টোর হচ্ছে গিয়ে হার্ড ডিস্কের মধ্যে। সো দিস আর দ্য 3 level of DBMS, and this is a very important question in the semester.